Now, keeping in mind that there's not one set right way to work a lot of these problems, you're going to notice on some of them that they're easier to work out just using like a conversion of a rate rather than trying to set up a full equation and solve. And this is going to be one of those problems right here. So again, if I read through everything first, right, I have budgeted $2,800 for fuel expenses for the year. The question here says, how many miles could you drive if gas were $2.70 per gallon and your vehicle averaged 28 miles per gallon? All right, so what I'm going to do here is I'm going to start with the gas mileage. All right, I'm going to write this as a rate, which is 28 miles per gallon. All right, and then I'm going to multiply this. All right, I want to make a conversion here. Instead of miles per gallon, I want to end up with a rate that's basically miles per dollar. Right? How far can I go on a particular dollar? Because then I can apply the number of dollars that I have. All right, and that rate is right here, right? The price of gas. So I'm going to put the gallons on top because I want my gallons to go away. All right, so this is going to be 1 gallon cost $2.70. And notice what's going to happen here is the gallons are going to go away, and now we have a rate, all right, that is basically telling me how many miles I can travel per dollar. So now what I'm going to do is bring in the amount of money that I have, which is a value of $2,800. And notice what's going to happen there. All right, these dollars are going to go away. I'm going to be left with just miles, and that's what I'm being asked. How many miles could you drive? So now all I have to do, like we did back in chapter 5, multiply across the top. So 28 times 2,800, divide by what's on the bottom, which is 2.7. That's going to give me a value of 29,037, and I do have some places after the decimal. All right, but if I look at my rounding, it says round to the nearest thousand, not thousandth, thousand. So if I round this to the nearest thousand, then I'm going to report this as 29,000 miles that can be traveled on $2,800. Now, this is not the only way that this problem can be worked, and so I just want to take a minute to show you kind of the other option that I could have used here if I set this up in more of an equation type. What I would have to do to use an equation here is I would first need to figure out not the number of miles, but the number of gallons that I could purchase, right? Because what we're given is a total amount of money, and we purchase gas not based on miles. We purchase gas based on the price per gallon. So if I do that, then I would initially set up my equation as $2,800, because that's what I have, is equal to 2.7, $2.70 times X, the number of gallons that I could purchase. All right, now, if I solve this, I divide both sides by 2.7, and that tells me, again, I'm going to round this to the nearest mile, that tells me that I could purchase 1,037 gallons of gas. So now what I'm going to do is I'm going to look at the gas mileage on my car, and I'm going to figure out how far I could go if I could purchase 1,037 gallons of gas. Right? So what I'm going to do here is take the fact that my car gets 28 miles per gallon, and I'm going to multiply that by the 1,037 gallons that I can purchase with my $2,800. And if I do that, All right, I take my 28 miles per gallon times my 1,037. That's going to give me a value here of 29,036. Now again, a little bit different than my initial answer above, but because I'm rounding to the nearest thousand, this is also going to show me that I could travel 29,000 miles on $2,800. All right, so again, my point here is, a lot of times there's not just one set way to solve it. So if you look at an example and you don't solve it exactly like I do, or you look at the view an example in my math lab and you don't solve it exactly the same way they do, but you still get to the right answer, that does not mean you did anything wrong. It just means you went about it a different way. And that's perfectly okay as long as you're getting the same end result. All right, now let's look at another example while we're here that deals with gas mileage and pricing of vehicles and comparing. And let's look at how we would approach this one as well. All right, so we're given information about purchasing a hybrid versus a non-hybrid vehicle. We're given information about gas mileage, and we're given information about a tax credit. The question here says, how many miles of driving will it take until the savings on gas make up for the higher initial cost? All right, so what I'm going to do first here is I'm going to compare the initial cost and figure out what that difference is that I'm trying to make up. All right, so for the hybrid vehicle, it costs $32,000, but it has a $500 tax credit. So essentially, right, the amount of money that I'm looking at for the hybrid is $31,500. Now the non-hybrid does not have a tax credit, right? So I'm looking at a purchase price there of $28,000. And that means the difference in the initial cost, which is what I'm looking at here, is $3,500. Now, that's what I'm looking at trying to make up. And I want to know how many miles of driving will make up for that higher initial cost. All right, now, because I'm trying to come up with a number of miles, and because each car has a different mileage rating, what I'm going to need to do first here is I'm going to need to figure out the cost per mile for each vehicle. All right, so if I start with my hybrid here, all right, gas cost $2.70 per gallon. The hybrid gets 34 miles to the gallon. So I'm going to divide that by 34 miles to the gallon. And that's going to tell me the cost per mile for the hybrid is roughly $0.0794. Right, the cost per mile. Now, for the non-hybrid, all right, if I do it the same way, gas is $2.70. It gets 23 miles to the gallon. So I convert this to a cost per mile of 0.1174, again, dollars per mile, right? That's what we're looking at here. How much does each car cost to drive per mile based on its gas mileage? All right, now, what I'm trying to do is look at the difference in the cost of driving, which is the cost per mile, and I want that to equal the difference in the initial cost. So my equation is going to look like this, right? I need to make up for $3,500 in the higher initial cost. And I'm going to do that by taking the cost per mile times X, because X is the number of miles driven. Remember, we're trying to figure out how many miles do we have to go before that cost is made up. So I'm going to take the difference in the cost of driving, and I'm going to set that equal to the difference in the initial cost. Because when those two things are equal, the difference in the cost of driving and the difference in the initial cost, then I will have made up for that higher initial cost. All right, so simplifying here, I've got 3,500 is equal to 0.038 times x, just combining like terms. To solve, I'm going to divide both sides by 0.038. All right, I'm getting a value of 92,105.26 is equal to x. I'm asked to round to the nearest 100 miles. So I'm going to report my answer here, rounded to the nearest 100, as 92,100 miles. And again, what we're answering here is how many miles have to be driven until the difference in the initial cost is equal to the difference in the cost of driving. And the cost of driving for each vehicle is equal to the cost per mile times the number of miles that are driven.